Hi guys, it's Mrs. Dietrich. How you doing? These are the notes for 7.2, finding cube roots. So just like we talked about last chapter or last lesson, we talked about squaring a number and then undoing it by square rooting. So today we're going to talk about cubing something, undoing it by cube rooting it, and getting back a value. So I'm going to start off with perfect cubes. It's a number that can be written as the cube of an integer. So this column here on the left, you probably could have done this a long time ago. So 2 cubed is 2 times 2 times 2, which is 8. You probably heard that that was 8 well before today, but 8 is actually a perfect cube because of the fact that you can do 2 times 2 times 2, and they're all the same factors, which gives you 8. So the next one I could do negative 3 times negative 3 times negative 3. Remember, negative times a negative is a positive, positive times a negative is a negative. 3 times 3 is 9. 9 times 3, so this is negative 27. 6 to the third is 6 times 6 times 6, which is 216. And then you have negative 5 times negative 5 times negative 5. Again, negative times a negative is a positive. Positive times a negative is a negative, so it's negative 125. So really the new thing is the next column. So what's a cube root? So a number when multiplied by itself and then multiplied by itself again equals a given number. So instead of starting with the cube and ending up with the result, I'm going to take the results and I'm going to cube root them to try to get back the factors that are required to multiply in order to get that number. So what times what times what gives me 729? Well, that's 9. What times what times what would give me negative 64? Has to be the same. It's negative 4. What times what? Oh, I'm sorry. I wrote that twice. What times what gives you negative 216, but it's got to be the same factor, and that's negative 6. So I want you to keep in mind, well, the cube root, like how is it similar to a square root? So like when I square rooted x, it was actually x to the 1/2. It actually is the same thing. You could put a 2 here, but you won't see it like that. There just won't be a number there. It's just assumed to be 2. However, if you take a root of any other number, then they put it here. So like the third root of x is x to the third. The fourth root of x is x to the fourth, so forth and so on. So the last thing is, how do you use your calculator to do cube roots? So you could do to cube something, you do caret, you could type in the number caret 3, hit enter, but for using your calculator to do a cube root, I hope you had a chance to watch the root video that I posted because it goes through your calculator and how to use it. However, I'm going to go over the steps right now. Okay, so second up arrow gives you this symbol where it's looks like a square root symbol with an X. Okay, this is your button that will do something other than a square root. However, you actually can use it for a square root, but since we already have a square root function in our calculators, you wouldn't use this for the square root. So say you wanted to do 3 square root of 8, and you were like, I'm not sure what times what gives me 8. So you would type it in 3, you do second up arrow, type in 8, and then you'd hit enter. And your screen should literally look like this. So it's taking the third root of 8, and then when you hit enter, you should get 2. So again, if you get a chance, check out that video. It's only like a minute and maybe like 40 seconds, and it goes through how to use this root button for something other than square root. I think they do something to the third root and something to the fifth root. All right, so example 1, find each cube root. So some of these I'll talk through just because they'll be easy to think about them in your head, but some of the others we're just going to use the calculator, and I don't really think there's anything wrong with that. So the third root of 8, well, we know 2 times 2 times 2 is 8. We've already seen that. So the answer for that one is 2. I mean, if you want to, you can put it in your calculator. You would do 3, type in 3, second caret, and then you type in 8, and then hit enter, and it can figure it out for you. All right, B, what times what gives you negative 27, but it has to be exactly the same factor, and that's negative 3. What times what gives you 1/64? So the trick with that one is, what is the cube root of 64? So 4 times 4 times 4 gives you 64. So since if you do 1/4 and you cube it, you get 1/64. So when you find the cube root of that, it's actually just a quarter. If you want to, you can type in, again, 3/2 caret. Because it's a fraction, I would probably type it in with parentheses surrounding it, just in case. I wish I brought home one of my calculators. You can try it by putting parentheses around the 1/64. You can actually let me know if it'll do it without, or if you need them. All right, the third root of 512, type that in, it's 8. If you do the third root of negative 729, so what times what has to be the exact same number. That's negative 9. What times what will give you negative 125 over 343, and it's negative 5/7. So make sure you saw this. And if you are using your calculator, it's totally fine. Again, make sure you check out that video, how to use your calculator. All right, so how are cube roots and cubing a number related? They are inverses of each other. In order of operations, cube roots are thought to be exponents, so you do them at the exponent step, just like when we talked about square roots. So what happens if I have the third root of 8, but I want to cube it? So that breaks down into, I just want you to see the progression. I know 8 is a result of 2 cubed, right? So if you're doing the third root of 2 cubed, well, you know that that's 2, but then if I'm cubing 2, I get back 8. So what would be our assumption? When you cube something being cube rooted, what is the result? And it's whatever's under that radical symbol or the root symbol. Hopefully that makes sense. Just like when we squared a square root, you get back whatever's under the radical. Same thing happens here. All right, so we are going to evaluate some expressions with, cub roots. I meant cube roots. I guess I have to change that. All right, so you can use your calculator for this. So because these are considered exponents in PEMDAS, so PEMDAS, so before you subtract, or this is actually times, you can't do any of that until you do an exponent. So this is going to be 2 times negative 6 minus 3. So I got to do times before I minus, so that's negative 12 minus 3, so it's negative 15. Again, you could be using your calculators to do this part. That is A-okay with me. All right, so part B is the cubing of a cube root, and if you remember, you can go through all the inside and simplify. You're just going to get back the 125. So 125 plus 21 is 146. Okay, you're going to do, again, this is considered an exponent, so this has to get done before you multiply, or before you minus. So I'm going to do 3 times 5 minus 8. 15 minus 8 is 7. Okay, so again, I have a cubing of a cube root, so I could go through and rewrite this and then cube it in the end like I did above with that example, but we know we get back whatever's under the symbol, which is 27 minus 4, which is 23. So there you go on those. All right, so example 3, evaluate an algebraic expression. So because there's a variable and they tell you what the variable equals, you're going to use substitution. So I'm going to take what this is, I'm going to put it here, I'm going to put it here. So 192 over 4 plus the third root of 192 thirds. Okay, so I can do 192 over 4. You have a calculator, hopefully, so that's 48 plus the third root. And if you divide the 192 by 3, you get 64. So I get 48 plus the cube root of 64 is 4. 48 plus 4 is 52. Okay, part B, we're going to substitute in for W. We're going to put in 1080. 1080. So I'm going to just take this, plug it in for W, 1080 over 30 minus 3 minus the cube root of 1080 over 5. So you could do 1080 divided by 30. You're going to get 36. So I'm going to do the third root of, I'm actually going to divide those and get 216. So the third root of 216, so what times what times what has to be the exact same thing, gives you 216, and that's 6. So the difference of the two is 30. All right, for our last problem, we have a cube. The baseball display case is in the shape of a cube. Use the formula for the volume of a cube to find the edge length S, and then find the surface area of the cube. So if it's a cube, the volume would just be length times width times height because it is a rectangular prism in nature. But because it's a cube, we know all the edges are the same. So I could do V equals side times side times side, or I could do side cube. So if I know the volume, I will substitute it in. So in order to get to S, you have to do something with S cubed. And S cubed is already by itself, so that's a good thing. There's nothing else around S cubed. But I'm actually, I don't know if you can see this in another color, I have to take its cube root. Whatever I do to the one side, I have to do to the other. So the cube root of S cubed just gives me back S. The cube root of 125 is 5. So an edge is 5 inches. All right, so that is part A. B is find the surface area. So again, this is a rectangular prism by nature. So you could do that LWH formula, and I actually have it on your notes, where surface area is 2 times L times W plus 2 times L times H plus 2 times W plus H. I actually think that's more work. So if it's a cube, you know all the faces are a square. The area of a square is side times side, so that's side squared. And there are 6 of them. So that would be surface area is 6 times S squared. I think this is a way faster formula. So I'm going to put in my edge, which is 5. Again, I have an exponent coming before multiplication. Again, still following PEMDAS. Okay, so 6 times 25 is 150 inches squared. And again, I did the other formula just so you can see it. Honestly, I'd probably do the formula on the left, if you could remember that. I don't know if that's on your formula sheet for 8th grade. You can look. But again, I think the one on the left is a little bit easier. All right, so this is the end of lesson 7.2. If you have any questions, you can always email me or come to my office hours. And of course, we need a bad punny joke, right? So why are square roots never sad? Because they're always positive. All right, I hope you guys take care, and I'll talk to you soon. Bye-bye.